need to move this over here so that everyone can clearly see. In 300 meters, turn left. Have you ever wondered how would a navigation app on your smartphone know where you are at a given point of time? Despite of the fact that the global navigation systems have become a commodity nowadays, not so many people actually understand what a navigation system is and how it works. Therefore, the goal of tonight's presentation is to briefly tell you what a navigation system is and show you how it works. In a nutshell, a navigation system is just a bunch of satellites flying out there in the space at a preset orbit at a known altitude around the Earth. The satellites are traveling at a known speed. Just for your reference, nowadays there are two major navigation systems available to the public: GLONASS and GPS. The satellites that are within a single navigation system form a constellation, and each satellite within a constellation is able to talk to its peer satellites. Each satellite is equipped with super precise and accurate clock. And at any given point of time, a satellite knows its exact position relative to the surface of the Earth as well as relative to its peer satellites. But the satellites aren't just flying there. They are continuously broadcasting a microwave signal that contains a message consisting of the satellite coordinates relative to the surface of the Earth and the time when the signal is being broadcasted. In turn, we have a receiver device that can capture the signals coming in from the satellites, interpret them, do the calculation, and at the end show us the location. Sounds simple, but it doesn't address the main question: how does it work? It is the process called trilateration, which is at the heart of the navigation systems. And this process, in turn, uses the principles of geometry of circles in order to determine an object location. I know this may sound like a very complex concept that is hard to understand, but in reality, it is based on very simple principles. And I'm going to show you how it works using the whiteboard to make it more visual. So imagine that we have a point X, a location of which we would need to determine. This point could be anywhere on the surface of the Earth. We wouldn't know. Nevertheless, we have a tool known as geometry of circles, which states that if we had a point, I'll name it point 1, with known coordinates and known distance to our point X, and if we were to draw a circle with a center in that point 1 and the radius equal to the distance to our point X, it would be guaranteed that our point X falls anywhere along that circle line. Well, this is better than nothing, but still doesn't help us to get the location, because the point could still be anywhere along this circle. And again, the geometry of circles helps us by saying, hey, if you have a second point, I'll name it point 2, with known location and known distance to your point X, and you were to draw a circle centered in this point 2 with the radius equal to the distance, the two circles would overlap at two locations, one of which would guarantee to have the location of our point X. Wow, this is amazing. We've just narrowed it down from the infinite number of options down to two possible locations. But there is still this little ambiguity, which one, this or the other? Again, the geometry of circles helps us by saying that if we have a third point with known location and again the known distance from our point X, and we were to draw another circle centered in that point 3, the 3 circles would be guaranteed to overlap at a point that is equal to the location of our point X. All great, but where would we get these 3 points? The answer is simple: the satellites. So imagine that this is the surface of the Earth. This is our point X. We got a satellite flying out there in the space and transmitting a microwave signal to our receiver located at the point X. That message, which is being transmitted, contains a location of the satellite relative to the ground of the planet, and all we would need to do is to find this distance, which would be the radius that we would need for the circle. How would we find that out? It may sound like a very complex problem, but in fact it's not. Because if we pay attention to this graph, we may notice that this figure here resembles a right triangle, a triangle with the 90-degree angle. And we might recall from the base geometry course from the high school that if we knew 2 sides of our right triangle, we would be able to easily calculate the third one. So we know this side already because that's essentially an altitude of our satellite orbit. How would we find out this one? Again, it's based on a very simple, well-renowned formula, which is distance equals speed times time. Do we know the speed? Yes, we do, because that's the speed of a microwave signal, which is the speed of light, a constant value that never changes. Do we know the time? Sure we do. Remember, I mentioned that the message transmitted by the satellite contains, in addition to the coordinates, the time stamp when the signal is being broadcasted. In turn, the receiver device, upon receiving the signal, registers the time when it was received. And then subtracting the send time from the receive time, it gets the difference, which is essentially the time that it took the signal to travel from the satellite to the receiver. So we have both values which allow us to calculate this length of this segment. So knowing this one and this one, we are able to calculate this distance that is essentially the radius that we need for our circles. Simple enough, right? Do you see a problem with the concept as I've outlined it right here? There is in fact a problem. The thing is that unfortunately we are not flat. We live in a 3-dimensional world, right? And in fact, instead of the circles in real life, we would be dealing with spheres, which would in turn leave us with an extra layer of ambiguity. And even if we had 3 known satellites, we would still end up with 2 possible locations, one on the surface of the ground and another one above the surface. To cut the long story short, to address that issue, that ambiguity of 3-dimensional world, we would need a 4th satellite that would be able to mitigate that ambiguity by similar calculations, just tiny bit complex because they are in 3 dimensions. And in addition to that, the 4th satellite would actually serve another important purpose. As I mentioned at the very beginning, each satellite is equipped with super accurate and precise atomic clock. But unfortunately, it's not cost effective to build in a $100,000 atomic clock into a smartphone. Therefore, unlike the satellites, the smartphone and the navigation app that is installed on it may just go off and be inaccurate at any given point of time. So it is imperative that we ensure that our receiver device has very accurate time, because it's crucial for our calculations here. And the process that allows the receiver device to sync up with the satellite constellation is called obtaining a fix. It may take some time. Therefore, when you're launching your navigation app or turning on your GPS device, you may notice that it takes some time for it to acquire your accurate location. Give it that time to ensure that you are getting the proper location of where you are. Okay, now to sum it all up, what do you have to take away from my presentation? The navigation system is a bunch of satellites flying in the space around the Earth along a predetermined orbit at a known speed. The satellites are continuously broadcasting microwave signal received by the receiver device. The signal contains the position of the satellite relative to the Earth and the time when it was broadcasted. There are at least 4 satellites required in order to ensure that you get proper, accurate, and precise location. And obviously, the process of syncing your receiver device up with the satellite constellation and navigation system, in other words, known as obtaining a fix, may take some time. So before you get going on your journey, allow your receiver device to get synced with the navigation system. You have finally arrived at your destination.